Hello everyone. So in this video, we'll be talking about the metric system. Now our guiding question for today in class is what are different ways to measure ingredients in a recipe, and does the way we measure matter? So in class, we did some experiments related to this. Those aren't going to come up as much in these notes because this is just the basic knowledge that you need to have to talk about these things. But this video will give you the basic knowledge so you can follow along in coming classes. Okay, so our key knowledge that we need is that we need to know the metric prefixes, so centi, milli, and kilo, and the units that we use for each of these measurements. Before we get to those prefixes though, we also need to talk about a couple of concepts called accuracy and precision. So I'm going to give you a definition for each of those, and then we're going to look at some diagrams. So accuracy is how close a measurement is to the accepted value. So we'll write that in. Oops. Okay, and then precision is how close a measurement is to other measurements. All right, so that's accuracy and precision. The best way to understand these is to look at a picture like this. Almost every introductory chemistry class will show you a picture like this, but I think it's a good one, so I'm going to show it to you as well. So each of these dartboards has some darts that have been tossed at it, and we're going to try and figure out were the darts tossed accurately or precisely or both or neither, assuming that this person is trying to hit the center of the target, the bullseye. So here, not very accurate, right? They're not hitting the bullseye. Also not very precise. They're kind of just all over the place. If I were to play darts, this is probably how it would go for me. So not accurate and not precise right here. Okay, now this person is not very accurate. They're not hitting the bullseye, but they are precise. They are throwing in the same location each time, just they need to maybe adjust their technique. They're throwing too far to the left and up for whatever reason. Okay, this person, if you average their darts overall, they would have an accurate score if you averaged them. If you said, okay, this one's here, the average is in the center. So that is accurate, but not precise. Now you could argue about, well, are they really accurate because they're never hitting the bullseye? But for the sake of this analogy, we're gonna say this is accurate. This picture, this person is accurate and precise. Okay, but let's go ahead and look at an actual science example here. So let's say you are an oil manufacturer in the food tech industry and you're making bottles that you want to fill with 1,000 milliliters of oil. So you collect some data showing how much oil is in each bottle after it's been filled, and based on this data, is the method that we're using to fill the bottles accurate, precise, both, or neither? So here are their different bottles, the times they filled them, and this is the amount of oil that was in each bottle. So would you say that they are being accurate, precise, or both or neither? Okay, for me, I would say this is precise. They're getting around the same measurement each time, around 991, 992. But they're not accurate because they're not getting to their 1,000 milliliters of oil that they want to. So that would be precise, but not accurate. Okay, so back to the notes. What I'd like you to do is draw a sketch of something that represents accuracy and precision to you. So you could draw a bullseye, just like we saw in that other diagram, if you want to. So you could draw like some darts. Those are accurate. And then maybe for precision, you could draw a similar picture, but maybe show the darts not in an accurate place, but in a precise place so you can keep those straight in your mind. Or if there's some other picture that you want to come up with, or if you want to put something kind of like this data table in there. Or if you think about sports, if you play a sport, say you play golf and you're thinking about, oh, like I might be really precise, but never get a hole in one if I'm always hitting the ball in the same place. That would be a valid example or sketch you could do as well. All right, so let's move on to the metric system. I don't want to spend too much time on the advantages of the metric system, but I'll just point out a few that you probably already are aware of. First of all, the metric system is great because it is based on 10, which makes it easy to convert between units. And then also, it is universal. It is used everywhere. And a lot of people will say, oh, in the US, we don't use the metric system. And it is true that we use a lot of other units, but we do actually use the metric system in a lot of cases. Or we'll have the metric system and our other imperial units. For example, on this can of beans, if you look right here, we've got the weight in ounces and grams. Or if you look at your speedometer in your car, it's going to give you a speed in kilometers per mile. Sorry, kilometers per hour and miles per hour. So we've got a metric unit and a non-metric unit. So it is useful to know the metric system, both inside and outside of the United States. All right, so let's talk about what some different things that we measure are, especially in this class, and what the metric units for those measurements are. So we're going to be looking at measuring things like mass and length, volume, temperature, time, and also density. Okay, and you probably know what metric unit we use to measure these. Metric units are almost synonymous with what we call SI units. There are a few differences, but we're gonna use them interchangeably here. So let's look at mass. Technically, the SI unit for mass is the kilogram. In chemistry, we're gonna be using grams more than kilograms, just because we're gonna be looking at smaller things. Kilograms are bigger, but the kilogram is the official unit, so that's what we're going to write here. In length, we use the meter. So the abbreviation for meter is M. And hopefully it's clear to you. I'm writing first the abbreviation and then the full word, the full unit. Volume is measured in liters, which is a capital L. And again, you do see liters like on drinks. If you go buy some soda, you will see that measurement in liters. Temperature is measured in Kelvin, which is a capital K. Now you probably thought I was going to write Celsius. And Celsius is used pretty commonly too, but the SI unit is Kelvin. If you've never heard of that, don't worry, we'll get to it pretty far into the year. But we will talk about what that temperature scale is and how it's different from others. Time is measured in seconds. That's a familiar one. And then density is a compound unit. It's got a couple of different units in it, but it is pretty important. So I'm going to tell you what it is, what units we use, either grams per milliliter or grams per centimeter cubed, which are actually the same thing. Milliliters and centimeters cubed are the same quantity of space. All right, last thing we need to know are just some basic conversion factors. So conversion factor just tells you how to convert from one unit to another. We'll be using these soon, but for now, I just want you to know 3 conversion factors for each category here. And these are one of the things that I really just want you to know by heart. They're not hard to remember, and they're really useful all the time. So you've probably seen these prefixes before: centi, milli, and kilo. Centi means 100. So the way that works out is, for example, in 1 meter, there are 100 centimeters. And you probably already knew that. You've probably seen a meter stick with 100 little lines, little dashes on there. Each of those markings is for a centimeter. So we can put the prefix centi in front of meter, and then it means the length that is 1/100th of a meter. So 1 meter equals 100 centimeters. But we can put centi in front of some other units as well. So for example, 1 liter is the same thing as 100 centiliters. You probably haven't ever seen that measurement before. 1 gram can contain 100 centigrams. So it's really important to remember always that centimeters, centiliters, centigrams are smaller. They're like 100 times smaller than we call this our base unit. So just don't start thinking that there's 100 grams in a centigram. That's not true. Centigrams are smaller than grams. Same thing with milligrams. Milligrams are smaller than grams. Millimeters are smaller than meters. So in 1 meter, there are 1,000 millimeters. So millimeters are pretty tiny. In 1 liter, there are 1,000 milliliters. You've probably heard of milliliters before. And in 1 gram, there are 1,000 milligrams. And you've heard of milligrams before. You've probably seen that on medicines or on like vitamins and supplements, things like that. Finally, we've got kilo. So kilo is a prefix that also means 1,000, but it means 1,000 times bigger. So let's put like kilo is bigger, milli is smaller. They're both 1,000, but that's the difference here. So there are actually 1,000 individual meters in 1 kilometer, or kilometer, but we usually say kilometer. So you've heard of that before, but we could also have a kiloliter with 1,000 liters in it. And then you've also probably heard of a kilogram. 1,000 grams makes up 1 kilogram. Okay, so these 9 equalities, these are really fundamental base knowledge that I want you to have just like easily accessible. You know them by heart, you know them like the back of your hand. We will practice these, we'll make sure that you've got them memorized. I'm not a fan of memorizing too many things, but there's a few things that if you just know them, it's gonna make your life a lot easier, and this is one of them. So with that, we will be done. That was accuracy and precision and the metric system.